right, for problem number 11, not as intense. For problem number 11, we're just going to simplify this. Now, remember, I said, think of this, perfect squares, 2 squared equals 4. 3 squared equals 9. If I'm writing it down, you need to be writing it down. 4 squared equals 16. 5 squared equals 25. 6 squared equals 36. 7 squared equals 49. 8 squared equals 64, and so on and so forth, right? 9 squared equals 81. Now, I wrote all that down because another way you could do this is you got to look at these numbers here. Does 4 go into 20? Yes. Yes. So I could think of this like this. The square root of 20 is the same as the square root of 4 times the square root of 5, right? Because 4 times 5 equals what? 20. Yeah. Now, what is the square root of 4? 2. So I want to, when I say there's two things, square root and square. When I say 2 squared, that equals 4. When I say the square root of 4, that equals 2. So when I do this, we call it square root, because we're taking the square root of it. When I do this, we say square. So 2 squared is 4. The square root of 4 is 2. And the reason for that is that I'm really saying the square root of 2 squared, right? Because isn't 2 squared the same as 4? Isn't 2 squared equal to 4? Yes. But remember, we have this index here. We don't write it down, but the square root is an index of 2, correct? Yes. Couldn't I rewrite that as 2 raised to the 2 over 2 times the square root of 5? Yes. See how that works? Now, what is 2 over 2? 1. 2 to the first power is just 2 square root of 5. Okay? So this is our answer. Any questions?